You are listening to Information Security Knows In Podcast, episode 33, originally released on November 12th, 2020. As always, I'm your host, Josh Amishav. In the past, we've had a lot of offensive security folks on the show talking about how to break stuff. Today, we have Tanya Janca on the show to talk about how to build stuff properly in the first place. Tanya is the founder of We Hack Purple, which trains folks on how to develop securely. She's also the host of a really good podcast aptly named the We Hack Purple podcast. If you're interested in hearing about all the different types of roles there are on AppSec beyond pen testing, then I highly recommend you go check out a show. My three main takeaways from our conversation were: 1, how to choose the right programming language to develop in when you're starting a project; 2, why we should get rid of as many JavaScript frameworks as possible within our code base; and 3, what drives someone to write a computer security book. You'll enjoy those 2 things plus a bunch of other tips along the way. Direct support for this podcast comes from BreachSense. If you need visibility into data breaches affecting your employees, your users, or third-party suppliers before their credentials are used to hack into your network, head on over to breachsense.io/contact to start your free 7-day trial and learn how you can prevent account takeover attacks and stop online fraud. And now, here's my conversation with Tanya. Tanya Janca, welcome to the show.
Thanks for having me, Josh.
So we're going to focus on secure programming today. And to start with, why is this such a hard problem to solve?
Well, the first thing would be is that part of computer science almost never includes secure coding. That would probably be the start of the problem, is that we are graduating people with a major in software engineering or computer science or from boot camps all over the place where you spend 4 weeks learning Java. And they just don't cover secure coding at all. Or they'll cover security, but it will be like identity and access management, which is extremely important, but that is not secure coding. It's like, imagine if they graduated all the electricians and never taught them safety. And they were like, oh, they'll just figure it out. It's obvious. Yeah, that's basically what we're doing. So that's one thing. I think the other thing is that you and I were talking a bit before we started, and you were saying, when we build a house, there's permits and you have to get your plans approved and all this stuff. But we don't have that for programming. And we don't have standardized components. So I actually am pretty handy and I like building stuff. So I built a greenhouse with my significant other in my backyard. And when you go and buy a 2x4 in Canada, it's not actually 2x4, which is silly, but it's the same measurement at every single hardware store that you go to. So you buy lumber and it says 2x4, and I know it's not exactly 2x4. It's like 1 3/4 by, etc. And when you buy it, it is exactly that every single time. But when we are going to go get a JavaScript framework, they're all different. And then they keep releasing new versions constantly. So imagine like my greenhouse is sitting there, but suddenly the 2x4s are 2x3s. And then, some of them aren't, they're not stud length. They're not exactly 8 feet. Now they're like 8'2". And it just like kept changing all the time. Eventually the greenhouse is going to fall down. All my vegetables will be squished. Or in this case, malicious actors manage to get into things. So I think that's a problem too, between like not having mass standardization and then also all the components you use to build your software, all the libraries, all of them keep changing. So yeah.
Is there probably available place to get at least inspiration for secure components for implementing various functions?
Yes and no. There's 2 companies that I'm aware of that offer, so you can subscribe to their service, and they have reviewed all of the components that are in their repository, and it will only allow you to download secure packages. So they've personally, they have a big team of security researchers, and they've actually picked through each one of them and reviewed the code and named them as safe. And so if you're starting from scratch, you could start with that. But if you have a legacy application or something, trying to tell a developer, 9/10 out of all the plugins you've chosen to use, you can't use any of those now. So just rewrite your app. That's not going to go so well.
And all the code examples you see on question sites maybe with problems as well. So if you're approaching a new project, then how do you suggest you choose the framework or the programming language?
I actually, I talk about this in my new book, which we'll talk about later, but it's Okay, so first of all, you want to start with a modern programming framework, like a programming language that has a modern framework. And you want to start with one whenever possible, first of all, that's memory safe. So Java is memory safe and C and C++ aren't. And for instance, Rust is memory safe. Now, Rust has other issues, like it's not as supported as C or C++. You can't find as many programmers that know it. There's not as many tools for it, but it's memory safe and it does low-level stuff. And so...
When you talk in memory safe, can you explain what that means?
Oh my gosh.
So just take a step back for those who may not understand. You're not talking about like buffer overflow protection.
Oh, I am,
Okay.
Josh. Okay, so when you assign a variable in a programming language, it puts it out into your memory and it has an area specifically for that. And so what used to happen with older languages is that you would say, okay, so what is your name? And then I would type in Tanya. It's 5 letters. It's nice and short. And let's say you've made your variable 20 characters long. So it fits. But what if Josh put in his name as Josh Supercalifragilisticexpialidocious? What would happen is that when it would go into memory, it would do the first 20 characters in where you said the variable would go, and then it would just overwrite everything else in your memory up to however many characters that is. And this could make your program crash. However, if you're very clever and quite evil about it, and you try enough times, you can overwrite the stack pointer. And that is the next instruction of where your code should be. And that is where the famous buffer overflow, integer overflow, string overflow variables come from, is the idea that if you can figure out how to overwrite where the stack pointer is and tell it, instead, look here, the next instruction is here, and it's your instructions, well, whoever wrote that code is going to have a very bad day because suddenly they're running your code instead, and your code is probably not signing them up for a new library card. Probably something not nice.
So besides for choosing language that's memory safe, let's say if you look at PHP, right, say legacy, somewhat of a legacy language, a lot of the code is riddled with various vulnerabilities, but you could probably write safe, secure code if you knew what you were doing. Are there languages that are more, I would say, I don't know, dummy proof that kind of mandate that you write more secure code than others?
Yes. So Ruby on Rails, they actually make it quite difficult to make injection vulnerabilities, and they have a lot of built-in protections for cross-site scripting. The .NET, so I guess like C# or I guess VB.NET, if some people still use VB. So if you're using the .NET framework, that has a lot of things in it to help you do the right thing. I guess when you're choosing, quite often what happens is if you're in a Java shop, you choose Java. Does that make sense? And you're like, everyone's just always going to choose Java. But Java has multiple frameworks. So you could choose Struts or you could choose Spring Boot. And I'm not sure if there's actually other Java programming frameworks, but I feel that there's a high likelihood there is. And so if you work in a Java shop and most of them are in Struts, when you do a new one, you could talk about using the new framework because Spring Boot has a lot less security issues than Struts does. And it's easier to program things in a more modern framework. And so I usually devs have preferences for specific reasons. So all of us know .NET, so we want to program in .NET. Great, but let's use the newest framework. Or we have no idea what programming language we're going to write in. Okay, so what things do you need? And then let's have a top 3 that we're interested in, and then security should be one of the things involved in that decision. I'm a firm believer that the AppSec team should always try to be there when the dev team or any tech team is trying to do an option analysis between choices, so they can try really, really hard to influence the team into choosing a secure by default type of situation, like Ruby on Rails, for instance. So I believe the Shopify is written in Ruby on Rails, and they have an AppSec team, and the AppSec team's actually been updating a whole bunch of the Ruby gems so they're more secure by default for everyone that's using Ruby. So that's like an ideal situation where some of the things are open source, so you can actually influence what your developers are using. I mean, I feel like that's getting pretty meta, but it's been working wonderfully for them.
Hey, you mentioned your book. Can you tell us a bit about the book and what prompted you to write it?
Yes. Okay, so my book is named Alice and Bob Learn Application Security. Alice and Bob are so A and B. So if you're going to tell a story or give an example for security, often people will use the characters Alice and Bob, because when we first were trying to explain what encryption was to non-math geniuses, they used the example of, well, Alice wants to tell Bob a secret. And so that's how they told the story. And since then, lots of security people have been doing that. So I have been using Alice and Bob in my blog and in talks for quite a while. And when I was working at Microsoft, so I was a cloud developer, security advocate person. My title kept it was a bit mushy. It changed a lot. But basically, I would give talks and write papers and stuff like that. And I remember them telling me, you really need to learn to scale. So you need to scale your activities. So you could speak at a meetup, or you could speak at a conference, or you can fly somewhere and talk to this many people, or you could stream and you could record it and then more people could see it. And so they're like, what if you fly less and write more? And I was like, that's a great idea. And then my blog started getting more and more popular, and publishers started reaching out to me and asking me to write a book. And I was honestly taken aback. I thought, I can't write a book. What are you talking about? And so then I decided to ask myself, okay, what do I wish that I knew when I was a dev? Like, what is every single thing that I wish I knew? And now that I'm an AppSec person, which thing do I wish they knew? And then I thought, if someone wants to become an AppSec engineer, there's no book or course that you could take. You can't just take a course and then be an AppSec engineer. And I'm like, why not? And I've seen there's the CSSLP, which I have not taken. And then there's some cool books. There's a book about agile security by Laura Bell, and that's cool. And then there's a book about DevOps security by Julian, and his last name escapes me right now, but that's cool. But what I wanted to do was write from A to Z, the very beginning, I'm going to design a web app. What requirements should I have for this web app? What is secure design? How do I design and architect a secure app? And how do I choose my programming language? And then, what is secure coding? So there's a big, long chapter on that. And it basically is the start to finish of the topic of application security, as much as I was allowed to fit into 250 pages, because that was my maximum number. That was allowed.
I never realized that was a thing. So for anybody who wants to become an AppSec engineer, this is the book.
Yeah, basically. And I would say the book concentrates a lot on secure coding, secure design, and is more a software developer's point of view. And then I've developed an online course that is more how to become an AppSec engineer, and then the book is the textbook for the course. But I feel what is an application security program? What things could be in it? Or how do you secure more modern technologies? None of this is covered in book format in its entirety. Do you know what I mean? If someone writes a book about serverless, they might have a section about security. But what if I want to know, the basics of serverless, and then the basics of, web services or APIs, and what's the difference? And so I just wanted to put all my knowledge I possibly could in one place. So then whenever anyone asks me, I can say, oh, that's in chapter 4. Because I wanted to scale myself. Does that make sense? I actually just submitted audio samples for a potential audiobook so one of the other reasons I really want to write a book is, so I'm dyslexic for real. I'm not one of those people that says I am when I've made a spelling mistake. And so I find certain things super easy to learn and certain things very difficult to learn. And one of my superpowers is the ability to break down a really complex idea into simple terms that the average person can understand. And that's what a lot of people comment about my talks and my blog. And so I wanted to make this the most easy to understand textbook ever. So Alice and Bob both have lives and jobs and health conditions, and Bob has grandchildren, and there's a divorce in Bob's family, and how InfoSec, like which security header you use, can affect Alice's health condition, or having your app designed in a way such that you can protect, Bob's photos of his grandchildren from being spilled onto the internet, etc. And so while it's not a fictional book, it's a textbook, there's these little stories throughout to help you understand how your decisions at work affect real human beings' lives. Yeah, I wanted to make it the most easy to understand book ever. So I start with the nerdy description, and then sometimes I have code, and sometimes I have diagrams, and I'm silly by nature. So, I mean, they did take out some of my ridiculous dad jokes, but they left some in. So for instance, I have this giant diagram about input validation. I wanted to call it Input Validation, the musical. But they're just no, it's not a musical, it's a diagram. I'm like, input validation, the diagram, with an exclamation mark. And they're like, how about no exclamation mark? I'm like, you guys are no fun. But they didn't take out all my silly jokes, and that's okay.
Awesome. So I like to ask guests about their contrarian views on AppSec. What's yours?
So I see so my company sells training, and we don't sell training on how to hack things. And a lot of people want that training. And I'm like, we don't sell training on how to become a pen tester. We sell training on AppSec and how to secure software and how to defend your software and things like that. And a lot of companies, it seems to be a bit of a trend. And they're like, yeah, we want to teach all of our developers how to hack. And I'm like, you have limited time with them, right? And you don't actually need your software developers to hack. You actually need them to write secure code. They're like, oh, they'll figure it out. I'm like, no, why don't you teach them what they need to do for their job? Don't get me wrong, learning how to do an SQL injection was super inspiring for me to go and review all of the code I had previously written where I was working. But I needed to learn how to defend, and yeah, I don't teach that. People are like, why not? I'm like, because I don't get it.
To what extent should developers have an understanding of things like cross-site scripting or various SQL, LDAP injection type attacks, as opposed to having the tools from a defensive standpoint to make sure they don't get into that, to introduce those issues to the code in the first place?
I would say that understanding the very common vulnerabilities is a good idea. So they know what it is, and they know what can cause it, and they know the defenses. But yeah, quite often people ask me for top 10 training, and I'll give it, a WASP top 10. But I'm like, memorizing the top 10 will help you with your coding, but how about I just teach you a lot of it? I'll tell you what the vulnerability is, but we're not going to sit here and exploit all 10. Instead, let's talk about what things we could do to stop them. If everyone does really great input validation, we were talking again before the podcast about the 80-20 rule. And if everyone validated every single input and just rejected every single bad input with, a nice vague error message, I don't think we would get rid of 80% of vulnerabilities, but I venture to guess 50%. Seriously, if we validated all the input from APIs, from serverless, from our own database, from any other app internal from the users, of course. But I think a lot of people, when I was a dev, I did not understand that we had to validate input except for that came in an input field from the user. It just did not occur to me as a dev many years ago that if something came out of the database that I might need to validate it. But if someone didn't do proper input validation when they put that data into the database, there could be an attack waiting there to jump out at my user. And that is the thing that happens. It's not that common, but it's common enough that, stored cross-site scripting is on the OAuth top 10 for a reason. And it's...
Let me ask you, so we talked about before about choosing a programming language. So if we're talking about input validation, would you suggest choosing a programming language that has input validation libraries built in, or do you think that you're going to have to do a case-by-case basis and do customized input validation for each specific field?
It is my firm belief that whenever possible, we should use the security features built into our framework. And so if there is input validation, I would want to use the one that is created like as part of my framework. However, validating an email input is different than validating a person's name, which is different than validating a username. And so I do think that we do need some specifics to make it clear. So for instance, someone could be named O'Connor, and that has a single quote in their name. And so then you have to figure out a way to accept that potentially dangerous input. But if someone has a username, I don't think we should accept single quotes or any special characters. You get A to Z and you get 0 to 9. And if that's not good enough, go use someone else's app. Do you know what I mean?
Yes. Can we talk a bit about supply chain security?
Sure.
So when you're developing, let's say, a web app, you're going to be using multiple third-party libraries. To secure that all those libraries, is it enough to use something like retire.js to look for old versions, or is there more to it than that?
I would say there are a bunch of things. So one, and I know software developers everywhere are not going to be pleased with this suggestion. One, I think we should reduce our threat surface, like reduce our attack surface by not including every single framework we've ever heard in our app. So like, we don't need to use this and this and this and this and this. Like every single developer on the team should not be using a different JavaScript framework. I have worked at places where they have 100 dependencies for like this tiny app. And I'm like, okay, what are we doing here? So I would start with reducing our attack surface and just, I'm not saying don't have cool frameworks. I'm saying don't have 20. So I would start with that. I said that at a conference in Australia and you could hear in the audience. And then I would do software composition analysis. So there are tools that you can buy, and there's a free one from OWASP called Dependency Check and Dependency Track if you're going to put it in a pipeline. But basically, software composition analysis tools, especially the ones you pay for, have security teams behind them that are reviewing all the popular frameworks to find vulnerabilities in those components, those libraries, those dependencies. So I would start with definitely running at least one software composition analysis tool, ideally before you push code every time. So if you are working in a DevOps shop where you're running your stuff through a pipeline regularly, add it to the pipeline. If you're working at a waterfall place, like have it scan your repo every Friday or something and have it automatically put those bugs into your bug tracker to work on, and then run a scan before, like as part of your final tests to make sure. If you can afford it, run two different ones. And I know all the people that make SCA tools object to that, but I don't work for them. And they have different security teams and different security researchers, like looking at the vulnerabilities, looking at all the different places, and they're not all going to find the same things. And there's lots of overlap. But when I teach courses and we do SCA, it's like, oh, look, this tool missed this one and that tool missed that one. And so like I report them to the vendors because that is the right thing to do, but I'm not going to find all of them and not everyone's going to report it, the difference. And so if you can afford two tools, I would. And if you can't, one is way better than none. But definitely like I've seen people where they use a tool that just bases like their scan results off of the CVE, like Common Vulnerability Enumerator database. And I personally find that super problematic because there is great stuff in that database, but there's a lot missing from that database because things don't always end up with a CVE. Does that make sense?
Yes,
so like
sure.
When I was a pen tester, I found a 0-day in a product and I'm under NDA and I can't tell anyone. So I told them to report it. And the client was like, we'll see. And they probably didn't. But let's say the client did tell the vendor, there might not be a CVE for it. So it's included in a patch somewhere, but that doesn't necessarily mean that the public is aware that that previous version of that product does have a big gaping hole in it. And I was not an amazing pen tester. Like, I don't mean to be down on myself, but I was like a junior pen tester and I found it. That means someone else that's like very, very experienced at security research could definitely find that. And if they have a malicious intent, they would do a different thing than what I do, which was tell my client, right? And so things don't always make it into the CVE database, even though I know they work very hard and I absolutely respect the work they do. I do not mean to say anything bad. I'm really glad they do that work. But the way the process works, not everything goes into there. And so if that's the only place you're checking, you're not getting an even remotely complete list. And that's problematic. And so that's why I usually advise you pay for a tool. Or if you have an open source project like I do, lots of them let you use their tools for free, which is a really great deal.
Cool. Yeah, I can definitely second that. I used to do a lot of work with OSVDB, which was a open source vulnerability database many, many years ago. And there were many vulnerabilities that we did not import into the database. Same with tools like Nessus development, a lot of plugins that we never wrote plugins for. So it's definitely an issue. Can we pivot to some of the more modern development frameworks? I don't know if that's the right word, but if somebody's coming from let's say a web app development background, and then they're pivoting to doing Lambda development, like web services, serverless functions, can they translate let's say the input validation, using that example? Is it enough for them to take the security features that they would have baked into their web apps and translate that into cloud functionality, or are there specific issues to cloud that they need to be aware of as well?
Oh yeah, there's so much stuff in cloud. Oh my gosh. So I feel like you just opened up like a gigantic can of worms, Josh. No, but
all right, bad question.
Well, no. It's an awesome question. I used to work at Microsoft, so I worked with the Azure team. And so I have so many thoughts about this. So when you basically, if your app is sitting in a really insecure place, then your app ends up being insecure. Does that make sense? So even if someone gets in not through your app, you still end up with egg on your face. And so when stuff was being released in a traditional data center, you had your traditional data center team doing their stuff. But I find that a lot of places are moving to the cloud, but they're not educating their staff on all the things to do with cloud and especially security. And it's so hard to find a qualified security employee that will come work for you full time that doesn't get whisked away to another company. Cloud security resources can be expensive if they're really good. And so, yeah, I find a lot of them are moving over, and it's not that the cloud isn't secure. In fact, I think it has the possibility of being even more secure. But if you aren't educating everyone on what the best practices are and architecting in such a way so that it is secure, then you end up with potentially a great big mess. I see, so the technical term is lift and shift, although some people call it something a lot more crass than that. But you can take your problems and then put your problems into the cloud, and then it is a problem that is just always available and really resilient. Do you know what I mean? And so, but I feel like a lot of companies, they don't really look at their legacy stuff and they port it into the cloud. And I'm like, when you're going to port that into the cloud, there's so many things you could do. You could do network segmentation around that. You could put a CASB, a cloud access broker security tool in front of that so that it adds multi-factor authentication on it and makes everyone go through this CASB gateway. So then you've authenticated them and done proper identity and all of this, and it's doing logging and stuff for you. You could add a RASP, a runtime application security protection tool, or a WAF if you're feeling old school. And there's so many things you could do to port stuff into the cloud and then make it really safe. But not everyone does that. And then bad things happen. And they're like, I don't understand. The cloud seems really insecure because this. And it's and you know that it's not that they're being negligent. It's just that they haven't got the level of education and training required so that they could do it. And employers are like, it's not my job to give you a new university degree. It's like kind of a catch-22 in the middle where the employees can be caught sometimes.
Okay, so if somebody wants to learn about this, do you have some tips in your book of how to learn what needs to be what bases need to be covered?
I do have a section in my book about cloud, and I have a chapter called Securing Modern Applications and Systems. And then I give you the best practices for like serverless infrastructure as code, cloud, etc. But it's only one chapter in a book that mostly is concentrating on how to secure software. So
okay.
It's the basics. I actually have a workshop that's on YouTube that I gave away for free, and it's how to secure Azure. And it is 2 years old or a year and a half old. So it's slightly out of date, but it's like how to turn on Security Center and how to do this, how to do that. And if you use the Azure free trial, you can do the whole training for free. And it's like 3 hours. I can give you a link to it after, Josh, and we could share it.
Great. I'll link that up in the show notes. Perfect.
And we talk about like zero trust and how to do zero trust in Azure. And we talk about like how to automate some of your policies, how to check up to make sure that multi-factor authentication is turned on and that it's actually turned on for everyone's accounts that have ownership over things. And yeah, because when I worked at Microsoft, they paid me to make content. I was like, oh, I get to give everything away for free. This is awesome. It's fun. It's more fun if more people get to have your content and then like become more secure because of it. Like as a content creator, like that's what you want, right? It's for people to have like value out of what you've created. Like you do this work because you like helping. And so, yeah, it's pretty awesome. I got to give away stuff for free constantly when I worked for them.
Awesome. That's great. We're about time. So if people want to check out your book, where can they find it?
So it is available on Amazon.com, CA, UK, etc. It's also available from Wiley Books, so Wiley. So if you just look up Wiley and Tanya Janca, you should find it. Or you could go to shehackspurple.ca. So my online moniker is shehackspurple. And so shehackspurple.ca has a link to my book and all my social media and all the stuff. Or you could become a student at wehackpurple.com and then everyone gets a book. Yeah.
Cool. Well, thanks for coming on the show, Tanya. And that's it for today. If you got any feedback or questions, then tweet at me at Jamus, JAMUSE. And if you got value from this episode, then please share it with a friend. See y'all next week.